To support this podcast, go to positivesarcasm.com/donate. Any amount is appreciated. Once again, positivesarcasm.com/donate. Thank you and enjoy the program. This episode of the podcast is brought to you by PB and Joey. Simple, honest, and delicious. Go to pbandjoey.com for more information and check out the trail mix. $35 or more gets you free shipping. That's pbandjoey.com for more information. pbandjoey.com. Jay here, PositiveSarcasm.com, recorded here at the Spare Parts Studios, the same state that Ghislaine Maxwell got arrested in. You can find me at +_sarcasm for Instagram, facebook.com/POS Sarcasm, or if you just want to be my friend on Facebook, go to facebook.com/positive sarcasm, TikTok at at Positive Sarcasm. You can also hit me up on the YouTube channels, Positive Sarcasm and Positive Sarcasm Podcast. Dropped another YouTube video last week for the retirement of Pelican. Had to go and dig through cloud. I had to go dig through Google Cloud services. I had to go dig through the archives in my server and find all the footage from the past, 3 years of flying that fucking thing. And boy, it's amazing when you look back at all the footage that I took. It's impressive. It's amazing what I've been able to track and how my cinematography has improved over the years, and just some of the shots I've got have been absolutely extraordinary. So go ahead and check that out on YouTube. It's only 3 minutes long, in and out, done. But it is a beautiful, scenic tribute to one of the first series of drones that was truly capable of commercial and safe enthusiast flying. So go ahead and check that out. That is the retirement of PS Pelican. Mavic Mini, or aka Firefly 1, makes a quick cameo in it, but Mavic Mini took some of the, or Firefly, excuse me. I like giving them all pet names because I treat them like pets. I give them it took some of the best shots because while Pelican 2 was up doing rotations in the air, the Mavic Mini was just sort of keeping track of it and getting some of those panning shots of Pelican 2 as it was flying by. So while Pelican 2 was doing automated flying in the air, the Mavic Mini was tracking it. So giving it a really cool shot. And in the background, you have like the ocean, you have the lakes region and the top of the mountains. And it was just a great, excuse me, a little frog in my throat. Just great footage and enjoyable to clip together and present to you folks. So go ahead and check that out. It's on Positive Sarcasm at YouTube, or just go to my website, positivesarcasm.com, and you can go ahead and check out the YouTube section. It's right there. I know that the news is crazy right now with all kinds of silly shit, but just so you know, there's actually people out there making true progress when it comes to science, at least just for now. And there's been a bunch of articles that I've been sitting on for a while as far as science and technology when it comes to space. And I know that SpaceX actually, by the way, welcome to Sunday Leftovers, everybody. This is the podcast that is usually half the length of the original podcast on Wednesdays. So SpaceX just launched and officially put dudes and chicks into space. I wanted to say that better, but there you go. So people are in space because of Elon Musk. Hooray! So they're out there. They're going to be making their way back shortly. And then he's going to be aggressively trying to get to Mars. He's putting a lot of his time and focus into it. Hell, he is actually renting a mansion. He's not even going to build. He's just renting out because he wants to put all his time and focus into getting to Mars. So good on him. And I wanted to just do this week. Or at least this podcast, just focus simply on space in general, because there was a lot of news and information that just came out regarding the Hubble telescope, the black hole collision, and warp drive. And I think it's super important. And of course, nuclear power has also made significant improvements with the fact that they have these highly resistant, meltdown resistant technology when it comes to called trezo particles. It's a type of fuel that the higher it gets, the safer it is. And that's going to be allowing us to build smaller reactors, more portable reactors for who the hell knows what, whether it's space travel, ground transportation, air transportation, military transportation, powering small rural areas on a budget. I don't know, but the technology is apparently there now, or it's in not clinical, but it's in initial trials, which is cool because considering that another isotopic detection was just supposedly came from Russia again, this time on a smaller scale, but let's be honest, another meltdown is something we don't need right now. But the first article of the day, this is Sunday leftover, so I'm rambling. Let me go ahead and get right to this first article. And this is mostly just a beautiful picture. You can go and check this out on bgr.com. It's from the Hubble. The Hubble snapped a picture of which galaxy is it? Let's see. It is come on, get out of here, Home Depot. I was just there. Stop freaking telling me what I should buy next. Let's see. Wait, is this it? Oh, fuck it. I don't like how when you go to like CNET or you go to certain websites, when you're scrolling down, it immediately goes to the next article, which is something completely different, and you lose your spot. It's kind of annoying. What is it? The Hubble Space Telescope captured an image of a distant galaxy called NGC 2775, 65 million light years from Earth. This picture is insane. And there has to be life outside of our planet. There has to be. I never really doubted it. Never. And especially if I look at this galaxy 65 million light years away. It's fucking gigantic. Millions of stars, millions of moons, millions of planets. Who knows what's going on in them? There has to be something else going on. And I really do want to get there. Because quite frankly, I think there's far more interesting shit to talk about. The fact that I'm staring at this image that on my screen is about 8 inches wide. But the vastness of this galaxy, I can't measure. Let's see. The galaxy is packed with young stars and features a wide open bulge in its center. Hubble's mission is a joint effort between NASA and the European Space Agency. Galaxy might seem special simply due to the typically huge size and collection of stars, planets, and typically a black hole or sometimes more. They're definitely interesting. Some of the clearly better looking, others, the Hubble Space blah blah blah, captures a stunning image during its lengthy tenure. It is a beautiful image. Galaxy you see here is on a feathered pattern. Okay. Galaxy is a real looker. Additional context. Thank you. The spiral pattern shown by the galaxy in this image from the NASA ESA Hubble is striking because of the delicate feathery nature. This flocculent, is that the word? Spiral arms indicate that recent history of the star formation of the galaxy, known as NGC 2775, has been relatively quiet. There is virtually no star formation in the central part of the galaxy, which is dominated by an unusually large and relatively empty galactic bulge, where all the gas was converted into stars long ago. The galaxy doesn't have well-defined arms like our own, but it's still considered a spiral galaxy due to its clear spiral pattern. That's not to say the galaxy couldn't evolve into something more akin to our own home galaxy, but from our own point of view, it's packed with baby stars and has a lot of life left to live. So I'm just curious, what are they talking about? And when we dive in a little bit more, what is actually going on within that galaxy? And all we got is basically a picture and some just initial calculations of, hey, there's a bunch of young stuff here. Great. I want to know more. Question is, how do we get there? Well, there's an article here about there's been some mentions about warp drive. This was back in May by Popular Mechanics. On reports of, is NASA actually working on a warp drive? Because there's light speed, which is basically the whole theory behind Star Wars, and then warp drive, which is the theory behind Star Trek. Now, is NASA actually working on a warp drive? Well, according to Popular Mechanics, here is the lowdown. Because, are they working on a warp? There has been some technology that's been possibly being able to fold space and time. And if we can do that, we can basically jump from spot to spot without really having to use force. Because we can put all the rocket boosters, we can strap all the rocket boosters in the world to our ass. We're not going to be able to go as fast as we need to get to where we want to go. It would still take decades and decades and decades. I mean, it took Voyager 1 and Voyager 2 let's see, 50 years just to reach the end of the solar system. 50 years. So, and that's just to power a small little thing moving at a certain speed that just strictly runs on solar power. Nobody on board, nothing of that nature. Just 50-year-old technology that just made it to the end of the solar system and is set to expire in the next 2 years. But as far as this propulsion system, is NASA work? I'll read the article. Internal feasibility report suggests that the agency might be, or at least the idea of traveling through folded space as part of the NASA interstellar flight menu. NASA has been they've have some life being breathed back into them because of the fact that SpaceX is now in the foray, and then there are other competing commercial companies such as Virgin Atlantic and Blue Origin, that pile of shit. Now, and then of course the government also pushing money into it as well. So NASA's kind of trying to make a comeback. And now that NASA astronauts being put into SpaceX shuttles. So there is some promise here as far as getting back to the moon, getting to Mars, and getting to other moons or whatever nearby. Cool, it's gonna happen. I think, because Elon Musk, he had a question about whether it's going to happen in his lifetime or not, which kind of depresses me. But in this report, advanced propulsion physicist Harold White, also known as Sonny, explains the idea of the theoretical physicist and Pierre Miguel blah blah. He then describes a paradox in his work, and how that paradox might be resolved to make a working module. The colloquial term warp drive has come from science fiction, and it refers to the idea of subluminal, less than the speed of light travel that conforms to Einstein's theory of general relativity, but still pushes speed to absolute maximum that's theoretically possible. In the Star Trek canon, progressive designs come closer and closer to the hypothetical barrier, the way real scientists continue to hew closer. Why does my dictionary in my brain suck all of a sudden? Hew closer and closer to absolute zero, and real-life light speed is a barrier. The Alcubierre drive, I should probably look up how that actually says. The Alcubierre drive works like physics versions of the classic party trick. The spaceship sits in space-time while science pulls the fabric from in the front of it to behind it like a tablecloth pulled out from under the full spread of dishes, White explains. Boy, we're going high level today, a little higher than I expected. The concept of operations as described by Alcubierre is that spacecraft would depart from the point of origin, e.g. Earth, using some conventional propulsion system and travel a distance d, and then bring the craft to a stop relative to the departure point. The field would be turned on, and the craft would zip off to its stellar destination, never locally breaking the speed of light, but covering the distance in an arbitrarily short period of time just the same. The theory dates back to 1994, and physicists have used it as a jumping-off point to further discussion ever since. By creating a kind of pocket world where a spaceship can operate seemingly outside of physics, the laws of physics can I have an idea. Can be sidestepped, or so the theory goes. What's the paradox? It's described this way. When the energy density is initiated, the choice in the direction of the plus axis is mathematically arbitrated. So how does the spacecraft know which direction to go? Science fiction has solved the paradox by inventing a stable wormhole. But White can't fly a Deus Ex Machina to Alpha Centauri. Holy shit. Did I miss that when I reread this article several times? Instead, he suggests a slightly different paradigm. In the modified concept of operations, the spacecraft departs Earth and establishes a initial subluminal velocity, and then initiates this field. When active, the field acts on the initial velocity as scalar multiplier, resulting in a much higher apparent speed. So creating a certain field allows the ship, basically, the vehicle, to get from point A to point B without actually having to travel at insane amounts of speed, essentially folding space and time. Instead of coming to a stop and then engaging the warp drive, the ship would use a rolling start as a directional cue. Okay. And then there's a bunch of fucking charts. But it looks like basically... Okay, York time magnitude decreases, surface plots. All right, that's popular mechanics. We think of warp speed as, well, the only faraway interstellar travel will ever be feasible. And White has focused on one mathematical paradox. We're eventually going to get to a point where I can understand what the fuck is going on, but we're going to keep reading. Not the only such obstacle. We suggest proving a ground for warp speed could be well closer to home. The idea of warp drive may be some fruitful domestic application subliminally. Allowing it to be matured. I'm getting my ass kicked this podcast. Before it is engaged to a true interstellar drive system. Okay. Negative mass. Thank you. If scientists can make the so-called negative mass required for an Albuquerque drive, even the tiny example could be deployed within Earth's atmosphere. Okay. Thank you. That's what I was looking for. Okay, so you have point A and point B. Point A being Earth, point B being Alpha Centauri or Jupiter or wherever point B is. Let's say we want to get to outside the solar system within a matter of seconds. What this drive or what this theory has to do is some type of drive that initiates a negative mass. So what it does is it takes the field of distance in front of the vehicle, and it creates a negative mass, which essentially is like a pocket that allows this bubble, this negative mass bubble, and it takes the item that is millions of light years away and essentially puts it right in front of the vehicle. And then all the vehicle has to do is slip through the bubble. And then once the negative mass is removed, the bubble pops, I guess. The net bubble pops, and the vehicle is no longer at point A. The vehicle is now at point B, whether that's the outside the solar system, at Jupiter, Alpha Centauri, millions of light years away. How long does it take to... the question is this negative mass, how do we create this bubble? How big can we make the bubble? What are the dangers of slipping into and out of the bubble? What kind of energy will we have to create to make that bubble? How do we get back? How do we chart that course, which I'm thinking we can? What stands in our way? And then overall, how long does it take? How long does it take to create the bubble? How long does it take to slip through the bubble? Can you get lost in the bubble? What kind of gravity and what type of risks are there for the vehicle and the people in it? I'm sure there's going to be some type of distortion, or does it just happen just like that? I don't know. I'm assuming the first time they'll try to do it is with just a simulated computer. A computer that's going to be like, run this macro, run this program, and the next thing you know, we go from this part of the universe to this part of the universe, and then come back. And then give us that data. We run the data. We do it again, and then we do it with people. Now, when you create this bubble, obviously, anytime you create a bubble, when a bubble hits something, like, for example, say you blow a bubble. Let's create a negative mass right now. We'll blow a bubble, and if we can, sometimes if you slip like a needle into that bubble properly, you can insert a needle. You can insert an object into a bubble without popping the bubble. If the bubble is strong enough, you can insert an object into the bubble without the bubble popping. Cool. However, if you create a bubble and the bubble hits a particle in the air, or the bubble touches something else that's on the outside. For example, you take a needle, you put it inside the bubble. Great. But then the bubble touches some other object that's sharp or what have you, and the bubble pops. Well, now what? That's a question. And there's all kinds of shit that's out there in space. Debris, asteroids, black holes, unknown objects, other ships that are traveling back and forth. Planets, remember those? Stars, heat, hot, cold, who the fuck knows? Atmospheres. How do we safely create a bubble for the ship to pass? First of all, the ship's got to get into the bubble, I think. Or we create, here's the thing. Are we creating a negative mass so that the ship can go over the bubble? Or are we creating a negative mass so that the ship can go into the bubble? That's the question. I'm thinking it's a negative mass, and then what happens is this negative mass allows space and time to collapse, and then the ship passes through that negative mass over the bubble. I'm curious. It's got to be one of the two. But you're creating a wormhole. Are you sucking the fucking ship into the wormhole, or are you creating some type of wormhole or negative mass so that the ship can pass over the top of it? I'm just curious. I'm just shooting out ideas. How does this work? I want to know the theory. And if somebody could please explain it to me, email me at positivesarcasm@outlook.com. How this bubble is created, how this negative fat mass is created so that something can pass over it, under it, or through it. I'm just curious. I want to know so we can get the fuck out of here. I'm also curious about this next thing. If we're creating a bubble, a negative mass, generally whenever you create something, anything that you create, whether it's negative or positive, there's always some type of equal or opposite reaction. So if we're creating a bubble, then what is it going to hit? Now, obviously, the scariest things in the universe that are a threat to us, that are a threat to our galaxy, our way of life, asteroids are number one. Okay, because they're visual. You can physically see them when they pass by, and they hit us all the time. So asteroids, number one. Number two would probably be black holes or gamma rays. Gamma rays is just gamma rays would be a massive burst of energy. Okay, gamma rays are a massive burst of energy. I don't think you can you see them coming, but you can't avoid them per se. Like they hit and they destroy everything. They're like, apparently from what I understand, from what I've read, gamma rays are the worst. Like, as a visual object, they hit and they just destroy everything. You can go ahead and check them out. Gamma rays are huge. They happen, I think, when stars explode or some shit. Then there's black holes. Now there's stellar black holes and there's supermassive black holes. Black holes have a single entity. I generally believe they have a single entity that lives inside of it. It's just like an entity that sinks and creates this massive gravity ball, and then things start to it's spinning. It's spinning at such a rate. The only way to stop a black hole is to slow it down. And the energy that's released from a black hole, if a black hole was to ever be destroyed, is insane. Now, black holes can get swallowed by other black holes. They can merge with other black holes. Most galaxies are formed around black holes, like the Milky Way galaxy that we are in. That's a black hole, and we spin around it. But according to Gizmodo, a black hole collided with something. This is the article I've been wanting to get to. If we're creating negative masses in order to slip through the space-time continuum in order to get to the next pizza parlor halfway across the galaxy, then is this something to be concerned about? Gizmodo has an article about a black hole that collided with something that shouldn't exist. So here's the main part of it. We're closing this article right here. Astronomers are not astrologists. Astronomers are puzzling over observations. Shows a black hole smashing into an object of unusual size. New research published in the Astrophysical Journal Letters describes a collision between a black hole and a yet-to-be-identified object. At the same time of the celestial tryst, the black hole was 23 times more massive than our sun, but the unknown object was just 2.6 times the sun's mass, which is distinctively weird. The scientists behind the newspaper, co-authored by astrophysicist Vicky Caligera, shout out to Vicky, from Northwestern University, say the smaller object could be a black hole or a neutron star, the latter of which is a super dense remnant of an exploded star. A black hole of 2.6 solar masses would be the smallest on record. The lightest known black hole is 5 solar masses. While a neutron star, the same mass would be the biggest on record. The heaviest neutron star between 2.3 and 2.4 solar masses. So either way, not something astronomers have ever seen before. And in fact, it could represent an entirely new class of dense compact objects. The discovery is quote, the discovery is shocking because we found an object with a mass we did not expect. An email to Gizmodo. The range of compact objects between 2.2 and 2.2 and 5 solar masses was thought to be uninhabited until now. He said in reference to an enigmatic weight class known as the mass gap. In my opinion, the most intriguing part of the study is that the detection of an object in the mass gap, which is sort of a no man's land between the heaviest neutron star and the lightest black hole masses we've measured. Unfortunately, it's impossible to say which it is, partially because the tidal deformation of a neutron star stretching that's usually detectable in a neutron star mergers is drowned. All right, so the reason I'm reading this article is that a black hole hit something. The question is, what did the black hole do? It hit something that wasn't supposed to be there, or something that we don't know about, or something that we do know about, but we've never seen it in this form. We've never seen it in this size. Now, a black hole generally does hit stuff. Now, a black hole, for example, the Milky Way galaxy is going to eventually collide with the Andromeda galaxy. That is the calculated collision course. They will hit each other. The question is, how? Will they hit each other and form a much larger galaxy? Because it's two black holes colliding with one another. Or will they bounce off of each other? Because sometimes black holes do that, but they do a dance. And then some of the planets or stars that are inside them go flung off into the unknown. But it completely changes everything. And God help you if you are on, well, he won't even help you, that if you're on one of these planets that hits it. I mean, there's going to be major climatic changes if you're on a planet at that point. You're just going to get flung. You're going to get flung. Understandably so, if you were sitting here right now and the Earth's gravity, if the Earth stopped spinning, I would become a pancake on the ceiling. This house would get ripped out of its foundation. Everything would stop because everything is sitting here due to a gravity, to a certain amount of gravity that's pulling from the center of it. If the Earth was to stop spinning, from what I understand, from what I've been taught, everything would just go fucking. I think planes would be fine. I don't know. I have to do some research on that. I don't know. Well, no, they wouldn't be fine because if everything was flying off the ground, planes would be screwed because they would have massive flak, human flak, dump truck flak, homes flying off into whatever. Everything would change. So it wouldn't matter anyways if that would happen. That's if Earth would stop spinning. But the idea of those two colliding together is understood. Galaxies are roaming through the galaxy. Galaxies are roaming through the universe constantly. They're constantly on the move, moving back and forth. It's always space is apparently expanding. It's going out. So obviously these galaxies are on the move. Eventually they'll taper off and start to rip apart. But what if we are creating negative masses and trying to get from one planetary system to another? When we create these negative masses, when we create these bubbles, are we going to run into a neutron star or a type of gravitational object that we're not aware of? And when we hit those, when the bubble that we're hitting, we got to know. When you're on a highway, when you're on a highway at night, you have GPS, you got headlights, you had police tracking, you have the Waze app, you have all these things that show you how you're going to get there as quickly and as safely as possible. Well, a deer or an animal can come out at any time and fuck up your day. The question is, what are we going to have? How do we chart safely from getting from one part of the galaxy or one part of space to another safely without running into, space deer or space moose? So I'm just curious. I'm always fascinated. I love learning about shit that I have no clue about. And space has a lot to do with science that I don't understand, math that I don't understand, formulas that I don't understand, last names that I can't pronounce. It's super cool to know that the Hubble is finding new galaxies every day. That warp drive, there are theories being worked on, and that we are still discovering new bodies of space that we've never measured, never seen before, and there are people out there that are super smart that are working on that and checking it out and creating theories and testing out what it is and how does it pose a threat to us or how we can use it in our favor. Because I remember I wrote an article back when I had a presentation to do in college. This is back when college still educated people. And it was about eventually how the universe is going to end. Well, in theory, there was the Big Bang or whatever, but we're here. But eventually the universe is going to continue to expand to the point where it's going to start to decay. And planets and suns are going to start to die off and start ripping apart. And eventually it all fades out into nothing where not even black holes can survive. And then you have just negative. You have nothing. Well, eventually nothing creates a vacuum and turns into something. And the next thing you know, a negative times a negative creates a positive. The next thing you know, poof. Another Big Bang or something to that effect. I mean, eventually, if we understand this technology enough, will we be able to create our own Big Bang? That amount of energy that we try to create eventually could power cities all on its own, just from a small amount of matter. You know, we're building these huge hadron colliders to understand what dark matter is and how we can create it, control it, understand it, utilize it safely. So I'm just curious. I want to know more about this stuff. I'd love to see this move into something where we can travel from planet to planet without having to, watch it on some random SpaceX YouTube channel with, it's cool to see a rocket hit 17,000 miles per hour and watching that whole process. But this is all this hard work just to get to the outside of our outside into orbit of our planet. That's it. All this effort and all this work just to get to the orbit of our planet. Not to get to fucking the moon, not to get to Mars, just to get to the orbit of our planet. So it's a big pain in the ass. It's a lot of work. So I'm hoping that this science and all this testing and all this theories can safely get us to another part of the galaxy that would take us decades, let alone decades to get us to outside of the solar system, alive. So, I don't know. Go and check out. This was Gizmodo. Black hole collided with something that shouldn't exist. Warp drive was on Popular Mechanics. That one threw me for a loop. I thought I had that one covered. That one is on Popular Mechanics is one where you're really going to test your IQ. And then, of course, BGR, Hubble Galaxy Photo. It's just a beautiful photo, so I wanted to share that with you. Go and check that out. We're at 33 minutes. I'm done for the day. That was a lot. That Popular Mechanics article kicked the shit out of me. You can hit me up on Instagram at +_sarcasm. You can hit me up on TikTok at +sarcasm. Facebook.com/POS sarcasm. We're going to get to some more shit that's near home. Well, on Earth at least. Next week regarding nuclear power. Maybe some drone footage. RIP to the Boeing 747. Go ahead and check that out. Boeing is officially ending the 747 due to lack of demand, and it's just not in the cards for them financially anymore. And then, of course, we will get to the Hong Kong situation coming up on Wednesday's podcast. But, of course, you can hit me up on social media. Check me out on my YouTube channels, Positive Sarcasm and Positive Sarcasm Podcast. Social medias. Donate, positivesarcasm.com/donate. Get ready for a wild week in the stock market, I think. I got some money aching to be put into the stock market this week, and I might pull the trigger. We'll see. Right now, the stuff that I have in there is for long term, and REITs are looking pretty good for next week. Even though the rally crashed a few weeks ago, things are looking up. So people are starting. I'm waiting for all the mortgage forbearances to end, so that people, I'll truly know how long do I have to wait until I can cash out, or not cash out completely, but at least cash out partially. So I'm enjoying that. But that's for another day. If you have money in the market, keep it, especially if it's in REITs. Keep it in there. Until then, I'd like to thank you guys for listening, watching, and subscribing. You can find, speaking of subscribing, iTunes, Stitcher, Google Play Music, Spotify, iHeartRadio, TuneIn, Podcast Addict, CastBox, anywhere where podcasts are available. Positive Sarcasm on there. You can also stream it and download it from my website directly, positivesarcasm.com. But thank you for listening, watching, and subscribing. If you have questions or comments, positivesarcasm@outlook.com. I will talk to you all on Wednesday recorded here at the Spare Part Studios. This has been a Positive Sarcasm presentation.